A plane can fly 700 miles in the same time it takes a car to drive 250 miles. If the car travels 90 miles per hour slower than the plane, what is the speed of the plane? Since this question is talking about distance, rate, and time, we will be using the formula d equals r times t. And specifically, it's different variation where t equals distance divided by rate. You don't have to remember this variation of the formula. All you have to remember is that distance equals rate times time. And to get this time by itself, you would simply divide both sides by r. And that results in t equals d divided by r, which is the same thing I have here. So we will be using this variation of the formula for this question. Similarly to many questions that involve this formula, there are two different trips happening. Specifically, for this question, we have a plane trip and we also have a car trip. Oftentimes, you might have a boat going against the river and with the river, or a plane flying against the wind or with the wind. But here we have two different vehicles traveling, and this is what we have for the plane and the car. So for our formula, we need the distance, the rate, and the time. So I will just create a little chart here that will describe all of the information that I have for the distance, the rate, and the time of both. So the distance of the plane right here is 700 miles, and then the car is 250 miles. So I'll record that in my chart. The rate, while I don't have a specific number for the rate, I do know that the car goes 90 miles per hour slower than the plane. So whatever the speed of the plane is, to get to the speed of the car, we would have to subtract 90 from it. So what I'll do is for the plane, I'll just make the speed the r. I don't have a number, so I'm making that a variable. And for the car, then it will be r minus 90. I have zero information about the time. All I know is that it takes the same amount of time for the plane to travel 700 and for the car to travel 250. So I don't have a number. I'm just going to use t for both, but I'm using the same letter because I know it's the same exact time. Now I will write this formula that I have in the box. For the plane trip, I'll write it right here. And the same thing for the car trip, I'll write it right here. So the formula tells me to write t first, so I'll write t, then equals the distance on the top and the rate on the bottom. So the distance for the plane is 700 and the rate r is at the bottom. For the car trip, I'm going to use this exact same formula and I'll use the information from the chart. So t is my time, 250 is my distance, and r minus 90 will be my rate. Now, since the times are the same, then I'm going to set them equal to each other. The 700 over r will be equal to 250 over r minus 90. This is a simple proportion, and what I'm going to do is cross multiply. So 700 gets multiplied by r minus 90, and 250 gets multiplied by r. Now I'll distribute the 700. And the next step would be to subtract 700r from 250r. So here I subtracted 700r from 250r, and that resulted in negative 450r. And finally, to get my r by itself, I will have to divide both sides by negative 450. So my r is 140. Now, going back to the chart, just to make sure that this is our answer, r in the chart is the rate of the plane, and we were asked what is the speed of the plane, so 140 is our answer. However, if sometimes these questions also ask for the speed of the other vehicle, the car in this case, and if I wanted to find that, I could easily subtract my 90 from the R, which I just found 140, and that would give me the rate of the car, which would be 50.